The next step is to develop the communication between the different systems. We use PLCs and HMI systems from Siemens System Simatic. You see here the different systems. This is PLC1, PLC2, HMI1, HMI2, and the PC system 1 and 2 for programming. This is a motion control system. I will give you a short overview of the Siemens TIA portal. On the left side we have the project tree, and there we see all devices we have in our project, PLC1, PLC2, HMI1 and so on. On the right side we have the hardware catalog, and with this hardware catalog we can place, for example, a controller, Simatic SIM300, and then the CPU of this type, and I can put this PLC on this place. The same with PLC2, and I found HMI1 here in the catalog. HMI Simatic Comfort panels, the most powerful panels today, and I take this one and place it on this position. That's the same with this one, and the same with the PLC system I found here under PLC systems, PC General, and this one I use for programming. The same with our motion control systems. This is a motion control systems, Dynamics S. The next step is to develop the network, and this device here has a Ethernet or Profinet interface. This too, and this has a Ethernet and Profibus device interface, and it's very simple. I can do this to integrate all systems in my net. So, and our motion control systems use a Profibus, and the PLC also has a Profibus interface, and I can install a Profibus system. This is a button for address labels, and I use this button. I can see all address labels. These are the IP addresses for all systems on the Profinet bus system, and these here are the Profibus addresses. This is a master. The PLC1 is a master, has address 2, and the motion control system has address 10. We have different types of communication. First, I will hide the address labels, and then we see here all devices, and on the network I see the PLC to Profinet I/O communication. This is a communication between PLC1 and PLC2. PLC2 is a controller for PLC1. and the cycle time is about 1 millisecond. And PLC1 becomes a peripheral component of PLC2, and the programming is very simple. I do not use any function block. I only have to transfer data to addresses, and this is very simple. The next communication is by Profibus. We have a Profibus system here, PLC1 DP master system. PLC1 is a master, and if I click here on the slave, the motion control system, I will see here the motion control system, and the motion control system use Telegram 111, and here are the addresses. I only have to transfer data to addresses, and this is very simple. Here we see the network, and now I change to connections, and then I have different connections, HMI connection, or another important connection, S7 connection. First, the HMI connection. The HMI connection is very simple done. I have only do this, and then I have the connection between HMI1 and PLC1, and I can do this, and I see this connection between the both systems. I do the same with the both other HMI2 and PLC2, and I have this connection. And the cycle time of this connection is about 1 second, because the human interface is very slowly, and I can control with PLC. With HMI2 can control PLC2, and with HMI1 PLC1. The communication between PLC2 and the robot is possible by Profibus. I will do this here, and this is a PLC DP master system, and we have communication between both. Another possibility is by Profinet, because modern robot systems have Profinet controller. The third possibility of communication between PLC2 and the robot system is by wire. If I click here on PLC2, I see PLC2, and there one module is a digital in 16 and digital out 16 wires, and the robot has the same wire, and so we have communication by wire. Inside PLC2 is another module, a communication processor for the ASI bus. The ASI bus can connect sensors to this PLC, and if you have a long conveyor belt, you have only one wire to connect all sensors. The communication we have used is cycle driven. The communication between PLC1 and PLC2 has a cycle time about 1 millisecond, and the communication here between those partners, the PLC1 and the drive for the rotary table, also has cycle time of 1 millisecond, and 2, the communication between those partners, PLC2 and the robot system. At the end of the configuration, I can have an overview to all addresses of all systems. Because the communication is cyclic, the programming is very easy. I only have to read or send data to these addresses. If I click on PLC1, I have an overview of all addresses for PLC1, overview of addresses, and here are the addresses for digital in, digital out, or other addresses. Here are the addresses for the Siemens Telegram, for the drive, and here the addresses for the transfer between PLC2 and PLC1, and so on. The same for the address overview for PLC2. I click on PLC2 and then I open the windows to see the address overview, and here I have all addresses for PLC2. Here are the addresses for the ASI bus, and here the addresses for the robot, and so on. If I choose connection, I see the communication between HMI 1 and PLC 1. The cycle time is by default 1 second, and I can show the communication between HMI 2 and PLC 2. If I use more flexibility in the production, then I can use an S7 connection. For instance, I can use this connection between PLC2 and PL1, and this S7 connection allows an event-driven communication, and I can transport many data from one partner to the other. Before, we have selected the HMI system here from the hardware catalog, HMI thematic comfort panels, 7 inches, and this type. But there is another way. I can, on the left side, the project tree, add new device. And here I select HMI. I select comfort panels and the same panel here. And now there is a HMI device wizard. For this panel, this is a very comfortable assistant to develop the HMI. First, there is a PLC connection, and I can select one PLC. Then this is now the PLC connection. Then the screen layout, the resolution, and so on. And then are the alarms. Here are the different alarms. Then the screens. It's very comfortable. I can develop a complex structure of screens. And the next, the system screens. System screens show us system information, and then the buttons here on the screens. The buttons are on all screens. And if I finish the configuration, then I have here a new HMI system with all complex configuration. The HMI system has another highlight, the order of configuration of screens. We have templates, for instance, for the navigation between the different screens. We have the screen for the HMI application. We have the global screen, for instance, for button you see on every screen. The most important screen is the system screen. This manages alarms from the system, our robot cell, and from the operating system. The global screen comes before screens and templates. Screens come before templates. With this technology, the HMI system is very powerful. The reaction time to detect problems is very short. The program language Siemens Graph, in international standard called Sequential Function Chart SFC, generates alarms automatically. By this way, the complex structure of the HMI system was developed. We have different access rights, and it is very comfortable for testing, for monitoring, and for the operator. The HMI systems have another highlights. Here the HMI 1 I change to runtime settings and to services, and there is a remote control. I can use Start Smart Server, and this specifies that the HMI device should operate as a smart server in runtime. Activates remote access to this HMI device from another HMI device. By this technology, you can collect many systems to a center point. There's another service here. This one I can read-write text. The use operate as OPC server. This specifies that the HMI device should operate as an OPC server. Enables access to the HMI device via OPC. By this technology, I can integrate systems from different manufacturers.